Hi, this program calculates the taxes that one has to pay based on their incomes. And the program has a sort of table it follows, and it's like what I show here. So for example, if the income is between 0 and 22,000, the person has to pay 15% of income taxes. If it's from 22,000 to 53,000, then the person has to pay 3,000 more or less plus 28% of the income minus 22,000, so on and so forth, as you can see in this table. The output of the program is the tax that the person has to pay. And that's it. Let's test it. So if we start by analyzing the variables, we see that the income variable is a double and it ranges from 0 to infinite. In here, I'm supposing no one has a negative income, which is definitely not true in real life. But let's start with this assumption. And the tax one has to pay also ranges from 0 to infinite. That's an output variable. There's no real dependency among input variables because there's just one input variables, although the output variable, the tax, is really dependent on what the income is. If we then go to the equivalence, partition, and boundary analysis, so the equivalent classes, they kind of emerge directly from the rules. So one for each, so 0 to 22,000, 22,000 to 53,000, so on and so forth. I pay attention to how the boundaries work, so closed boundary from the left side, open boundary from the right side. Then we can do boundary analysis, and for the two sides, as we have been doing so far, so we have 0 and 22,100 as on points, then minus 1 and 22,101 as an off point. Just a note here, so I said that those variables were doubles. So if they are doubles, the off point here, the best off point here would be like really the next possible number that is really close to the on point, right? And maybe if we are in the double world, and let's suppose we round numbers up to 2 decimal digits, then 22,100.01 is really the off point there. Yeah, I'm just using integers here because that just facilitates this Excel spreadsheet and how you look at it. But remember that because this is a double, then the off point is not the next integer number available, but maybe the next small change in the digits that you can do. Okay, then we repeat this for all the other boundaries. Those numbers are too big for me to say, and I'm afraid I'm gonna make a mistake when I say them. Just found a typo here. And we just keep doing it. Once we are done, maybe we can even think about an invalid class. Let's suppose minus 1 or a negative number is invalid in this problem, so we can also exercise it. And then we can just, well, try all the boundaries now. Yeah, focusing on the boundaries again as a way to prioritize which tests to do. As you can see in this table, there are some repetitions, right? For example, these two here are repeated. You're not going to do them twice. So then we do them all. And you can see them here. Yeah? Exactly. 12 tests. So this exercise was actually very similar to the ones we've seen before. Okay?